last week we talked about the resistive circuits, and in this week we will talk about some more about RLC circuit. So it will involve some of the differential equations, but so actually this week we'll talk about the RLC circuits. So in the first part, I will talk about some simple stuff first, which is to find initial values and final values. For the circuits, with DC source. So actually, to finding the initial values and final values would be easy. It does not involve any differential equation. It will be something like to solve a resistive circuit. So let's check an example. Okay. So the circuit look like this. So this is V and this is I. And this is a switch which is closed for a sufficient long time before t equals 0, and the switch is open at t equals 0. So in this question, the switch has been closed for a long time. Which means it is at the steady state. Which means at the steady state. This does not include in the question, but for a long time means at the steady state. It is open at t equals 0. It is open at t equals 0. Find. There are lots of stuff to be found. Wow. I0 plus V0 plus B dI0 plus dt dV0 plus dt dV0 plus dt. So we find the initial value for the zero order and the first order derivative. And C, we find the final value of I and V, So actually it is quite simple. Okay, so first of all, we try to find I0 plus and V0 plus. So for part A, so it is closed for a long time, which means that the circuit will look like this. This should be 12 volt. So for t is smaller than 0, the circuit will look like this. 12 volt. This is 4 ohm, and it is at the steady state, which means that the inductor is a short circuit, and this is 2 ohm, and the circuit is closed, and the capacitor is open, which means that this is open, and this one is short circuit. So it become a single wire, and the capacitor is open. So actually, it is just remove open for capacitor, short for inductor, and this is V, this is I. So this is nothing but solving a resistive circuit, and you know that V or maybe I first, I0 minus. Actually, we find is I0 minus and V0 minus. So I0 minus is 12 volt over 4 plus 2 ohm. So this is 4 ohm, this is 2 ohm. So it will be 12 over 6, which is 2A. And the current for inductor is continuous. So we know that I0 plus is 2A. And also, we can find that V0 minus is I is 2A, and this path is open. So I0 minus also go to here, which means that V is nothing but 2 times 2. The current is 2, and this resistor is 2 ohm. So it is 4 volt. So for the voltage for a capacitor is continuous, which means that V0 plus is 4 volt. V0 plus is 4 volt. So this is the answer for part A. And for part B, we would like to find the first derivative for I and B at 0 plus, at t equals 0 plus. So for part B, well, So actually, what we need to use is the inductor. For the inductor, VL 0 plus VL 0 plus should be equals to L d I 0 plus dt. Yeah. Yes. So actually, we will have di 0 plus is dt equals 1 over L VL 0 plus like this VL 0 plus. And what is VL? VL is actually here. VL. This is plus, this is minus. So the voltage difference between this node and this node. And hopefully we know that V0 plus is 4 volt here, 4 volt here. And so actually we need to find what is actually VL0 plus. So we know that VL0 plus should be 12 volt minus 12 volt minus 4 times I0 plus. This is 12 volt. So this node is 12 volt. 12 volt. This is 12 volt, and this voltage will be 4 times I0 plus. So this 12 volt minus 4 I0 plus, also minus VO plus, also minus V0 plus, which is 12 minus 4 times this is 2, and this is 4, which means that VL0 plus is actually 0. So that as long as VL0 plus is 0, so we know that this is also 0. If you really want to write the SI unit, it should be the current over the time, so which is A over S. So this is one of the answers that we would like to find. And the other one is for the capacitor. We would like to know that actually IC0 plus should be C dV0 plus dt. So we will have dV0 plus dt equals 1 over C IC0 plus. So the next step, we would like to find what is IC0 plus. Actually, IC0 plus is this one. So actually, I equals IC plus the current in this branch. So we'll know that. IC0 plus is actually I0 plus minus V0 plus over this current is actually V0 plus over 2 ohm for the current going in this branch. So which is V0 plus over 2. So in this case, we know that I0 plus is 2A minus 4 over 2, which is 0. So in this case, IC0 plus let me see, I0 plus is 2A. Oh, sorry. We don't really need to minus this one, because for t equals 0 plus, the switch is open. So this is not correct. So it's actually this one. So because for t equals 0, the switch is open. So at t0 plus, there is no current going in this path. So actually IC0 plus is actually I, which means that IC0 plus is 2. So here is 2 over, what is the capacitance? The capacitance is 0.1 F. So it is 20. SI unit is V over S. So this is the answer. So this one is dI0 plus dt, and dV0 plus dt is 20 volts per second. So this is the two answers for part B. And for part C, we would like to find I infinity and V infinity. So for part C, we can draw the circuit. So at t tends to infinity, so on the left hand side there will be 12 volt. This is 4 ohm, right? So this is 4 ohm, and the inductor is also short circuit. So this is an inductor. Could be short circuit, and that path is open. So the only remaining stuff is the capacitance. So this one is open, and then a series of capacitor like this. So this is V, this is I. So actually this is a capacitor, so it will be open. Turns out to be open. Here, capacitor to be open. So in this case, I infinity will be 0. And V, as there is no current, so this is 12 volt, this is also 12 volt, because there is no current here. So this is 12 volt, 0 volt. So V infinity is 12 volt. So this is the answer for part C. So actually finding the initial value. Finding the initial value for RLC circuit is quite simple. Okay, so next, let's go to another example. So this is 3 UTA. This is 2 ohm. This is VR. 4 ohm. VC. One half F. 20 volt. .6 Henry, and this is IL. Okay. So in this circuit, calculate A IL0 plus EC0 plus, and also VR0 plus. And for part B, the first derivative, dVC0 plus dt, and then dVR0 plus dt. The part C is IL infinity, VC infinity, and also VR infinity. So first, let me explain what is UT. UT is what we call a step function, which is 1 for t is larger than 0, and 0 for t is smaller than 0. So if you try to plot it in a graph, it will be something like this. Something like this. If this is 1 for t is larger than 0, this is UT. So we call it a step function. We call it a step function, just like going up a step. So first, for part A, which means that this current source is 0. This current source is 0 for t smaller than 0, which means that this path is open. This path is open. And let me see. So actually there will be no current going through here, and thus there will be no current going through here. So this node will be 0 volt, this node will be also 0 volt. In this case, VR 0 minus is 0. And VC 0 minus will be, this is 0 volt, this is 20 volt, so VC is minus 20 volt. And IL 0 minus will be 0A. So in this case, we can write that VC 0 plus is minus 20 volt. IL 0 plus is 0A. But what is VR 0 plus? Actually, VR 0 plus is not 0. VR 0 plus is not 0. Okay. So we would like to find what it is. Let's see. So we know that this voltage, the voltage here should be 0, should be 0 volt, which means that it will look like this. This is 3 for t is larger than 0, so it is like so for t equals 0 plus. And so this is 2 ohm. And this voltage is also 0 at t equals 0 plus, which means that it will simply like this. And which means that the resistance is actually 2 parallel 4, which is 2 times 4 over 2, 2 plus 4, which is 8 over 6, which is 4 over 3 ohm. So for VR 0 plus, so VR 0 plus is actually 3 times 4 over 3 ohm, which is 4 volt. So this is VR 0 plus. This is so this is the answer for part A. And for part B, we'd like to find the first derivative of these three variables at t equals 0 plus. So let me see. Maybe IL would be a easy one to find. Yeah, IL is easy to find. So actually, let me think. So this is an inductor, so which means that it will satisfy VL 0 plus equals L d IL 0 plus dt. So we can get DIL 0 plus dt equals to 1 over L VL 0 plus. And we know that VL 0 plus is actually here. It's actually VL here. So we know that VC 0 plus is minus 20, and this is 20. So this is 0, this is 20, and minus 20. So this is also 0. At t equals 0. So VL 0 plus is 0, which means this is 0. So this is actually 0 over L, which is 0 volt. So this is so this is one of the answer for part B. And next, we may find VC, the first derivative of VC at t equals 0 plus. And it is an inductor, so we can write that IC 0 plus is actually CdV VC 0 plus dt. And thus we can write that VC 0 plus dt is actually 1 over C IC 0 plus. Yeah, so actually we would like to find IC 0 plus. So actually we know that VR 0 plus is 4 volt. VR 0 plus is 4 volt, So this node is 4 volt, and this node is 0. So the current here at t equals 0 plus the current here, the current going this way should be 1A at t equals 0 plus. And we know that IL0 plus is 0A. So this is 0A, which means that all the 1A would go to here, which is IC0 plus. So actually IC0 plus is 1A. So this is 1 over C is 1 half. C is 1 half. 1 half. So the answer will be 2. This should be B over S. No, this is A over S. This should be A over S. This should be A over S. And this is V over S. So this is the second answer for part B. And for part C, we would like to find dVr dt at t equals 0 plus. So how to find this at t equals 0 plus? So actually, we know that actually we know that at t equals 0 it will look like this, which means that as long as we have a figure like this, this is 3A, this is 2 ohm, this is V out. So this is 4 ohm like this, and we may call it VO. So in this case, we can write 3 equals VR over 2 plus VO over 4. So actually we take the derivative from both sides. So 3 is a constant, so can write it like this. So we take the derivative. So that on the left hand side, the derivative of a constant is 0. And for this case, we have a dVr dt. And this is 1/4 dVo dt. of course, we can also find that for this loop, we have an equation. We have a circuit like this. So we have a 20 volt here, and this is a capacitor, and this is VO, which is 4 ohm, and this is VR. So we consider this loop with KVL, so that actually we need to be careful about the current, but so we consider the KVL at this loop, which makes it VR equals VR, and it is actually VC. This is actually VC plus VZ plus 20. Likewise, we take the derivative on both sides. Take the derivative for this equation, so that we will have d VR dt equals dVO dt plus dVC dt. So this is equation 1, this is equation 2. So we will try to eliminate VO, dVO dt. Actually, in this for equation 1, you can write that dVO dt is minus 2 dVR dt. And then we substitute this into equation 2, so that it will be something like dVR dt equals minus 2 dVR dt plus dVC dt. So we can have dVR dt, which is 1/3 dVC dt for t is larger than 0, and of course this will be true for t equals 0 plus. And actually dVC 0 plus is 2 volt per second. So this is 2 over 3 volt per second. So this is the third answer for part B. This is the third answer for part B. And for part C, so for part C, we would like to find the free variable at t equals infinity. So in this case, we can redraw the circuit like this. This is 3A. this is 2 ohm, this is 4 ohm, and the capacitor will be open, and this is still 20 volts, and this one will be short circuit for an inductor. So this is IL, this is open, and actually this is VC infinity, IL infinity, and also VR infinity, VR infinity, like this. So in this case, so VC is simple. So VC infinity would be the easiest one because this is open and this is short. So this node is ground. So this node is 20. So it's the same, minus 20 volt. And the next one, we may find that so actually this is more or less the same circuit as this one, which means that the voltage here is 3 volt, right? 4 volt. It's 4 volt, which means that, so we know that the voltage here is 4 volt. This parallel resistance 4 ohm and 2 ohm will be 4 over 3 ohm. So this is 4 volt, and in this case IL infinity would be 4 over 4 volt over 4 ohm, which is 1A. And actually we know that VR infinity is 4 volt. So this is another example for finding the initial value. So let's have a break, and in the next part we'll talk about some example about the second order circuit.